Okay, hey guys. I just want to show you some stuff. Here we have this one. Okay, this is this is a bolt modeled. Um, this is a bolt modeled from the just using Fusion 3/4 inch 10 UNC, and this we this I modeled this. I've shown you this before. Um, there. This bolt is modeled. This is the download from the McMaster Car. Is that what it's called? McMaster Car website. Okay, you've seen that before. So these are pretty much close identical. This is the one that I modeled using um, Inventor, and I did the threads in Inventor myself by what I did. I can tell you basically is I did the 3/4 inch shaft, and then I put a coil on it that had a pitch of 10 of point 0.1. It's for a 3/4 inch 10 UNC. That's 10 threads per inch. So if you put a mic on it, you're gonna get 1 inch. You're gonna get 10 threads from crest to crest. Obviously, you can't see that, but I can verify it for you. That's 10 threads. So fairly decently accurate. And then this guy here, I modeled with the 5/1000ths of an inch. It's in fusion threads with a 5/1000ths of an inch tolerance. Okay. Okay. And now here's a nut. The nut was modeled in Fusion using their threading tool, their threading tool just straight 3/4 inch 10 UNC, and it goes so far on the bolt using the Fusion modeling. The McMaster car bolt, it goes so far and stops. I even sanded this one down a little bit, but even if you sand down the width of the crests, it's still tight. Okay, so the one that I threaded using Inventor, it actually works. I don't know why. Maybe my thread angle. Maybe I used a 60-degree thread angle. I think that's the same here. It should be. I don't know, but for some reason it works pretty good, pretty tight and smooth. And the 5/1000ths of an inch bolt, okay, or the minus 5/1000ths of an inch, it works great. It's looser than that one, so depending on how you want, how much give you want. But if I were to clamp this onto something, I'm sure I could tighten it up pretty well. So that works. Um, and that's my Inventor bolt and my tolerance bolt with a standard fusion thread. That right there. Okay. Now this nut is the nut that I modeled with 5/1000ths of an inch tolerance. So it's minus 5/1000ths of an inch. Okay, so on the inventor or the fusion thread, the original fusion thread, it works. Works pretty good. The master car bolt, it also works. It's probably a little better because I sanded it down a little bit. The bolt that I made in Inventor works great. It's a little loose, but not that bad. And the bolt that has a tolerance on it, I engraved these, so I think it's pretty cool. Good way of identifying your stuff. I put the tolerance on it. So now the bolt and the nut both have the tolerance, and you can see that it's a little. My computer's doing something. There we go. I'm back. It's a little. It's got a little wiggle to it, but not horrible. So good to know. I tried. Let me show you something else here. A project that I'm working on. Let's pull this out. Make a little clamp. Okay. This is a fun piece I did in Fusion. I would love to offer an advanced solid modeling course so we could do more stuff like this. But like with the solid modeling course, the time that we have, you can get as far. You can only go so far. It also depends on how motivated you guys are. Anyway, back to here. I modeled. I am such a slob. Alright. This is one of the jaws, and this is very flimsy. And this isn't the jaw I want because this jaw does not have threads in it. That's the other jaw. Kitty. Where's the other jaw? I just had the damn thing. Sorry about that. I had the darn thing a minute ago. Anyway, there it is. It's behind me. This is the jaw. This jaw has threads. This one doesn't. This one's got a tolerance. Goes through like that, and then it's to thread in. Anyway, so doesn't thread. So I did a little test thread with the 5/1000th of an inch, and yeah. So I'm going to run this again with 5/1000th of an inch. Now let me show you what I did here. Okay. Let me see. Can I do this? Can I flip it? Can't. That's unfortunate. Okay. Well, I'll just do my best. I'll do my best. Alright. The printer, I got one of these see it? There we go. Old school USB cables. I'm trying to show you that you can actually see it. Okay, there we go. These old school USB cables from my old phone that I don't even use those anymore. Put it in here. All right. Hello. Got that right? There we go. and then the other end into my computer. And let's go back to. I'm a pro. I'm a visual communications pro. Anyway, go back to Kira. So here's my part. Now, when you plug this in, well, let me unplug it for a second. You go to monitor and you get nothing. Okay. When you plug it in, plug it back in, you go to monitor, and this pops up. And I turn on my printer, and when let me switch back. You're not gonna be able to see it. Let me do split screen. So I'm gonna do a split screen. Why is that in my way? Okay. Anyway, you're not seeing this. When I hit the all right, let's just do this. Wait, no, that's cool because you're getting that. When I'm so confused. I'll put the camera on the printer. There we go. That's how this is going to work. I hit the home button. And it starts to home. Okay? So I can control everything here. So if I go back to prepare, and then since this model has got these overhangs, I'm going to change this up and add supports, which I did, add supports, and then do the slice. About an hour. It's not showing my supports, but I'm gonna hit preview. There they are. That's gonna be a pain. Oh well. But yeah, I had to do it on the other one, so it's not too bad. Now I can print via USB or click here, save the file. Via USB is basically through the USB cable to the printer. So I'm going to hit print via USB, and you can see it starts preheating the build plate. I probably should have done a preheat, but once the build plate gets up to temp, it will start heating the extruder, which I didn't think it did that. You did it directly from the USB from the ender, but be that as it may, you can see that it is in fact heating up. 34 degrees, 34.9, 35 degrees there. So now I don't have to fiddle with that little inky dinky card. One thing that I did read though is that turn off if you're going to try doing it this way, which is very convenient. You don't have to fiddle with the little card. I guess that's the biggest advantage to it. But one thing that I did read up is make sure that you turn your power saver off so that your computer doesn't shut down. So if you got like a 3-hour build, excuse me, if you got a 3-hour build, make sure your computer doesn't turn off, because I don't think the information, it doesn't send the information to the printer, it keeps it in your computer. So you need that USB connected, and you need your computer turned on the whole time of the build. So if you're going to do a long build and you're not going to be around and you don't want your computer running, then I would use the card, little card they give you. So with that said, this is not your next assignment. I'm just showing you what I'm doing. We're gonna go on to a different type of using a different type of. We're gonna go to snaps. Plastic parts, when they fit together. And anyone in plastics has probably encountered this before. The little snaps that you use to fit pieces together. If you got, like, say, 2 pieces, some sort of case, you snap them together. That'll be next. I don't have a lesson up for it yet. We'll probably get it up early next week, if not this weekend. But I want to encourage you guys to print, okay, anything. And if you print anything, take a picture and send it to me in an email. This isn't required, but I want to see what you're doing. I'm curious on what you're doing and how you're using the printer. Okay? All right, guys. Until next time, see you later. Bye from the cat. And I'll let you know how this goes.